Here are some review problems for Chapter 3. First, let's look at this data for the commuting distance for 11 employees. One of the employees lives in another town and has a large commuting distance. That would be the 120 miles here. The mean for this data is 21.9 and the median is 14. The question is, which of these two statistics would most accurately represent the center of the data and why? In this case, because we have the 120, which is an outlier, or we could also call it an extreme value, that would have a significant effect on the mean. It would make the mean larger because this is a large value. So the median would be a more accurate representation of the center of the data. In this case, it's the median because there's an extreme value. The median is what we call resistant because extreme values and outliers don't affect it significantly. Whereas the mean is affected by extreme values, so we say the mean is not resistant. Now we're going to look at histograms for two different groups. First of all, we want to look at the histogram and try to determine which of the two groups has less variation. If we look at these two histograms, more variation means that the values are more spread out. Less variation means that they're closer together, more bunched up in one area. So definitely for this one, this graph would have less variation. That's also true because for this graph, there's a significant outlier. This would be a very extreme value. It's one value that's very, very far away from the rest of the data values, and that would mean that there would be much more variation for this group. So the one with less variation is condition 2. Then we can think about which one would have a larger standard deviation. More variation means a larger standard deviation, and outliers or extreme values affect the standard deviation a lot. Having this one outlier would mean that this group would have a much larger standard deviation than the other one, which doesn't have an outlier. So the one with the larger standard deviation would be the condition 1 group. Now we already talked about the condition 1 group having an outlier. Now let's look at which group would have a smaller mean. Remember that the mean is affected by extreme values. The fact that this group has this extreme value way out here, that would actually add a lot on to the value of the mean. Whereas for this group, since all their data is pretty close together between 0 and about 12, the mean would be lower for this group than it would for this one. For this one, even if it didn't have the outlier, the mean would probably be larger, just because these values also go out to a much larger number than these values do. So the one with the smaller mean would be condition 2. Now we have some statistics for two variables, hourly wage and age, from a data set. Of the 6 statistics that we have shown here, the question is which one would be the most appropriate to use in comparing the variation for the two variables. So again, we're looking at which one has more variation, which one has less variation in the data. The statistics that are on here that have to do with variation are the standard deviation, the range, the IQR, and the coefficient of variation. The mean and the median are measures of center, so they don't even come into this. In a situation like this where we have two different variables that would have different units, if we've got hourly wage, that would be measured in dollars. The age would be measured in years. So since these units are completely different, then really these 3 measures don't tell us much because we've got such different means for these two. If we look at the mean for the hourly wage, that's about $9. The mean for the age is about 37. So looking at the standard deviation, that doesn't really tell us which one has more variation. The one we want to look at is the coefficient of variation, because this takes into account both the standard deviation and the mean. Looking at the coefficient of variation, it's larger for the hourly wage. That would mean that this has more variation. If you look at the other 3 measures of variation, for all of them, the age has a larger value, but that's because we're talking about larger values for the age in the first place. In this problem, we're looking at some box plots. This time we have 4 different groups. So first let's find which one has the largest median. Remember that the median in a box plot is the line in the middle of the box. So we're looking for which one of these has the line that's the furthest to the right, and that would be this one. So that would be for the false group. The IQR is actually the difference between the first and third quartiles. On the box plot, it's the width of the box. So if we look at the width of each box from the first quartile to the third quartile, the one that's the smallest, that's the narrowest box, would be this one. That would be the miserable group. The minimum value is the end of the left whisker. If we look at all three of these, they're the same, but the neutral group has its left whisker a little bit further to the left. For the largest Q1 value, the Q1 is the left end of the box. So we're looking for which one of these is the furthest to the right in our graph, and that would be this one. That would be the miserable group. And then the most variation, this goes along with the IQR. A bigger IQR means more variation. So for this one, we're looking for the one with the widest box, and that would be this one. This one would have the largest IQR, or if we're just looking at the box, it has the widest box. In this problem, we're looking at z-scores. Remember, to find the z-score for something, you take the data value minus the mean, and then divide by the standard deviation. You have to be careful how you do this if you're using a calculator. So first, let's find the z-score for 99.7. What we're going to do is take the 99.7 minus our mean, which is 98.2. And we want to do this whole operation first before we go to divide by the standard deviation. If we subtract these two, we're going to get 1.5. Then we're going to take that value and divide by our standard deviation, which is 0.62. And then we're going to round this to 2 decimal places. So this is our z-score. So again, be careful how you do this on the calculator. What you'll find out if you put it in your calculator like this, and don't put any parentheses in there, you're going to get an incorrect answer. So it's really better to just go ahead and do the subtraction first, and then after that do the division. Do it in 2 separate steps. The other question here is whether this would be considered an unusual value, either significantly high or significantly low. For that, we're looking at the z-score. If the z-score is either more than 2 or less than -2, then it's considered an unusual value. So yes, this one would be. Since the z-score is positive and it's more than 2, that means we consider this a significantly high value. So our original temperature of 99.7 would be considered significantly high. Let's do the same thing for this one. We're finding our z-score, taking 96 minus 98.2, that's going to give us a negative 2.2. Your z-score will always be negative if your value is less than the mean. Then if we take the negative 2.2 and divide it by 0.62, we're going to get approximately negative 3.55. Now we want to think about whether this is an unusual value. Yes, it is, because it's less than -2. And we would say it's significantly low. Another thing we can do is compare 2 z-scores. For this one, we have 2 different test scores from completely different tests. They have different means and different standard deviations. So a good way to compare things like this is to find the z-scores. If we want to find the z-score for the 3.5, we're going to take 3.5 minus 6, which would give us a negative 2.5. Then we're going to take negative 2.5 and divide by our standard deviation, which is 1.2, and that gives us approximately negative 2.08. So again, this is less than -2. That would mean we'd consider this an unusual value. It would be unusually low. Then for our other one, for the 420, we would take 420 minus the mean for that test, which was 376. That gives us 44. Then we would take the 44 and divide by our standard deviation of 42. That gives us approximately 1.05. The question with this one is which score would be considered more extreme. For this, we're looking for which one is further away from 0, and that would be this one. The one that's further from 0 is the one that's more extreme. So the 3.5 score is the more extreme of the two. Then in this question, this is talking about IQ scores, and it says right away that they have a bell-shaped distribution. That's kind of a keyword to look for. That usually means that you're going to be talking about the empirical rule. And remember, that's the one with the picture of the bell-shaped curve. In this case, we have a mean of 100. The mean always goes right in the middle of that curve, and a standard deviation of 15. And they're asking what percentage of IQ scores would be between 70 and 130. We can start with our mean and go up and down by standard deviations. And what we want to do in this case is just keep going up or keep going down until we reach these numbers. If we start at 100 and go down by 15, that would get us to 85. If we go down by another 15, that would get us to 70. So there's one of the numbers we were looking at. That's 2 standard deviations below the mean. If we start at 100 and go up by standard deviations, if we go up by 1, that would get us to 115. If we go up another standard deviation, that would get us to 130. That was the other number we were looking at. So the 70 and 130, that puts us within 2 standard deviations of the mean. What the empirical rule said was that if we're within 2 standard deviations, that should give us 95% of the data. So this in here would be 95%. So the percentage of IQ scores that are between these two scores would be approximately 95%.